Hello everyone, this is Shreya Chakrabarti from Sri Venkateswara College of Engineering, holding the USN of 1VE 21CS 163, presenting a video of embedded system and software under the guidance of Ma'am Miss Chaitra Raj, Department of CSE. Hope you like the video. Don't forget to share, like, comment and subscribe. So let's begin. Introduction to Embedded System. An embedded system is a combination of a computer hardware and software designed to perform a specific task. Here, the embedded system works as a pathway of connecting the software to the hardware conveniently, easily for the users. It can be an independent system or a part of a larger system. Embedded system does not need a criteria that it should be only being inbuilt into some part of larger system only. It can also work as an individual system. Leading to the third point, these embedded systems can work without human interventions or with little human interventions. Most of the embedded system, it's not specific that they need the human interaction at its peak. Sometimes it works as without human interaction also. There are three main components of the embedded system, leading to the first hardware, software, and the firmware. Now, beginning with the hardware component. The hardware component needs three things: power supply, processor, timer controls. Now, the power supply. An embedded system requires power supply to function. The requirement is typically 5-volt supply or range from 1.8 V to minus 3.3 volts. It should be smooth and continuous, where the source can be a battery or a wall adapter. Here the power supply, in power supply they are not specific that they need it from a battery as well. It can be from any of the sources. Wall adapter also can be used. It needs a range of 1.8 volts to minus 3.3 volts. Okay. The next topic begins with the processor. Processor is the central part of any embedded system. It decides the performance of the system. Now the processor decides the capacity, or the processor decides the efficiency, or the processor decides the kind of performance of the system. These type of processor available are at 8-bit processor, 16-bit processor, 32-bit processor. Lesser bit makes for a smaller application for the embedded system. Large application requires higher bit processor in the embedded system. Like the embedded system comes into three variants: 8-bit processor, 16-bit processor, 32-bit processor. These bits are decided by the user that at like what performance they need. They need a higher performance, higher processor, higher storage, so they will be leading to 32 bits or 16 bits. But if it's a user dependent thing, if the user doesn't want that much high processor, they can also go with the 8-bit processor. Now coming to the time counters. The counters, some application requires the delay. Like in LED display apps, some delay is required so that LED can continue to blink. The time between the blinking, the LED needs some time, so that time is known as the time counter. To blink, the time needed to blink, the gap between the LED, once it blinks, the blink 1, then the gap, and blink 2. So the gap between those blinks are time counters. For this purpose, timers are used in the embedded system. For this specific purpose, timers are used in the embedded system. Now moving on to the second part of the embedded system. The first was hardware. Now beginning with the software components. Software components consist of three things: emulator, assembler, and compiler. Now the emulator is a piece of software that allows you to run the host system functionality. The host system functionality is allowed to use because of the piece of software that is an emulator. The emulator tool can control all the components, like it can control every component. The emulator is also used to track down flaws and debug software. Like in any software, is there any code, any error, then the emulator helps it to debug the software, or it helps to track down the flaws and correct it. The code was also transferred from the host system to the target machine via the emulator. Now the assembler. When the programming language used to design the application is assembly language. The assembler is sued. The assembler language programmer is subsequently translated to HEX code, which can then be processed further. The programmer is then used to write the program in the chip after the code has been written. Compiler. A compiler is a piece of software that converts a programming language into a language that the target machine can understand and use to carry out the functions. Now, the work of compiler is kind of translation. It translates the programming language, any high level language which we write, the programming language which we write to gives the instruction. That programming language is converted to the machine language through the compiler. The compiler's primary function is to translate high-level code into a low-level language. Machine code, object code, and assembly language are examples of low-level languages. Now comes the real-time embedded system. A subcategory of embedded system is the real-time embedded system. A real-time embedded system is a type of a computer system with timing constraints. That is, a system which responds to external events or input stimuli in a timely fashion within a finite or a specified time. Consider a weapon defense system whose job is to shoot down incoming missiles and protect the naval destroyer. This weapons defense system consists of three subsystems: a radar system, a control system, and a weapon firing system. A control system acts as a command and a decision system, which is controlling system, and the radar and weapon firing systems are the control system. There are some real time of applications of the embedded system, the application of embedded system, where these embedded system up till now, which we have just went through the slides, where these embedded system are being used, what are the application, what are the uses of the application embedded system. Let's begin. The first goes with the latest smart TVs. The smart TVs are using embedded system. A GPS navigation system uses embedded system. Almost all the modern day smartphones, every modern day smartphone, every smartphone which we use in our day-to-day life consists of an embedded system. Missile guidance system, space exploration, automobiles, industries, assembly robots. Robots are using embedded system. It's the inbuilt of the function which we using to control the robot, to make it function, to make it do some specific tasks. There are the embedded system which are using, which are we used. The road safety system, traffic monitoring and collision alert system. Here the as we have seen the road safety system, traffic monitoring, the signal turning from red to green, green to red, red to yellow. All these functions are done without of with because of embedded system. Without the embedded system, it's not possible, and many other systems. Beginning with the programming language for embedded system, the embedded system, which are we like looking into since the very first slide. What are the languages which we can use to write into the embedded system? What are the languages which can be used to give instructions to the embedded system to control it? Here are some listed below. First comes with C programming. One kind of a one particular part they have made embedded C, C++, Python, Java, ADA, Assembly, Rust, Lua, Verilog. Some of these are familiar to us like C program, C++, Python, Java, Assembly, and many others are not familiar, that much familiar to us, but these are the languages which we can use. These are the languages which we can help turn the embedded system to the complete instruction set. We can turn it to use the embedded system into a way better manner. Here comes the end of the video. Hope you have liked the video, understood the video. Comment, please like, share and subscribe. Thanks for the recent visit to my channel.